Principles of Bioproduct Separation, Module 6, Adsorption, Segment 3, Adsorption in a Continuous Stirred Tank. With me, Yusuf from School of Life Sciences and Phenology, Institut Teknologi Bandung. We have previously discussed about chemistry of adsorption and batch adsorption. In this segment, we will discuss about adsorption in a continuous stirred tank. A continuous stirred tank is also called a continuous stirred tank reactor and tend to be used for larger scale separations than those carried out in batch. Feed enters the tank continuously at a flow rate h and a constant concentration YF. The tank initially contains pure solvent and unloaded adsorbent W. The concentration of solute on the adsorbent Q varies with time. Solution flows steadily out of the tank, but its concentration varies with time. However, because the tank is well stirred, the concentration in the tank equals that in the outflow. The measurements in the small tank are essential, for they characterize the kinetics of adsorption. The qualitative behavior expected in this system is also shown in the figure. Even if there is no adsorption, the concentration Y leaving the tank will vary with time. If adsorption is infinitely rapid, Y will rise quickly to a low value and then increase slowly until the adsorbent is loaded. Then Y will rise in much the same way as when there is no adsorption. In most cases, adsorption will occur at a finite rate. This case will lie between the other two, as shown in the figure. The mass balance of solute in the liquid is shown in equation 14. A similar mass balance in the absorbent gives equation 15. Two limiting mechanisms are common. First, adsorption is controlled by diffusion from the solution to the adsorbent. Second, adsorption is controlled by diffusion and reaction within the adsorbent particles. When diffusion in the solution controls the adsorption, the rate R is given by equation 16. For example, if adsorption follows the Freundlich isotherm, the adsorption kinetics expressed as the mass transfer coefficient K is a function of stirring in the tank, but not a strong function of the temperature. When diffusion and reaction within the adsorbent particles control the adsorption, the rate R is given by equation 17. The expected adsorption rate is independent of stirring in the tank, but is usually a strong function of temperature. In the next segment, we will discuss about adsorption in a fixed bed. Until then, I am Yusuf from Institut Teknologi Bandung.